Alrighty, so the first one is about the shopping mall and what kind of sampling it is. So you survey those who ask the shopping mall, so they are choosing to participate, so that's self-selected. Survey the 30th household in town, that's a system, so it's systematic. And then survey all households on 6 randomly selected streets. So it's every house on that street. That's going to be a cluster. Now the next one is 5 randomly selected households from this part of town, 5 from this part of town, 5 from this part of town. And so that's sum from all. So that is stratified. There isn't a simple random sample on this one. It would say something like, oh, they took everybody's name in the town and put it in a hat, and then they picked 30 people or something like that. Okay, next. Same thing, but with a class council. So this one's going to be systematic. You don't even really need to read it. But once you start to see that every 15th student, every 10th student, then that's going to be systematic. Those who ask the class council for a questionnaire, that's self-selected. The convenience one would be like they asked every person who is outside of the ASB room, right? Because class council usually hangs out in ASB, maybe not class council, but something like that. That would be convenient for them because that's where they hold their meetings. So that's why that is not convenient. This is self-selected. The council randomly chooses 3 students from each second block class. So the groupings are the classes. Are they picking everyone in some of those classes, or are they picking some from all of those classes? This one is 3 students from each, so that's going to be stratified. And then now they're picking all students in 5 of the classes. So there's like 30 classes, but they're only picking 5 of them, and they're going to ask everyone, and that's cluster. So when it's all the kids in the class or in the group, all has 2 L's and cluster has an L. That's how I remember it. Okay? Moving on, these right here, surveying the weight of 50 puppies would be quantitative. Ethnicity, I know I'm skipping B, is categorical. Favorite color, categorical. Test score is quantitative. And then this is where I might throw you for a loop, because a zip code is actually categorical, because it's a number that's just being used for a city. It's like just, right? It's used for a city's name. It's the same thing, like, do you need to know the average of a zip code? Like, what would that tell you about the city, about the country that you're in, if you figured out that the average is 47623? Like, literally that tells you nothing about the type of city, versus knowing the average weight of the puppies is pretty important. Did they have large puppies or small puppies? Are they going to be healthy? So that just that can get a little tricky. Another situation where you might see a number answer that's categorical is jersey numbers. So players have numbers on the back, but they also are just numbers representing their name, right? Who the player is. Does it benefit you to be like, the average jersey number is 27? There's nothing there. Same thing with like grade levels, like kindergarten, first grade, second grade, third grade. Like, those are just saying that what grade you're in, so it's not necessarily something you need an average on. Okay, this one right here says to select all that apply. More females prefer strawberry than vanilla. So we're going to go to the strawberry and then the vanilla. We're not even going to look at the males for this right here. And that is true, right? More males prefer chocolate than females. Well, it looks like that's not true. Strawberry was the least preferred by males. So here's male, here's male, here's male, and that's the lowest one. So that's true. And males prefer vanilla the most. Is that also true? Yeah? Okay. This one right here is from 15.2. This is the probability one. We, as a Math 3 team of teachers, decided that we're going to keep the probability on this exam very, very simple. So we're not doing the ands and the ors and all that kind of stuff. We're just going to do it from the table, just like this one. So this is the extent of 15.2 on your exam. So the first thing that it says is, what is the probability that someone likes Mexican food? So there's no given or based on the condition. So we're going to take the total, which is 166, and then we're going to find the total that like the Mexican food. That would be me. And 42. Wow, that's low. And then you would just use your calculator to reduce your fraction, which is going to give you 21 over 83. Okay. What is the probability that someone likes American food and is a teacher? Again, doesn't say anything about condition. So you're just going to go into your table and you're going to find American and teacher. And that lines up right there. So then that's going to be out of 11. The next one, there's two ways to do it. What is the probability someone does not like Italian? You can either do 1 minus 56 over 166, because 56 over 166 is the probability that they do like Italian. So the complement of that is that they don't, so it's 1 minus that number. Or you can just say they don't like Italian, and you can go, okay, well, 42 plus 68 is 110. And there's 168 people total. So there's the 56. Sorry, I wrote the wrong number. There's the 56 people, and then reduce your fraction. So either way is fine. Then this last one does use the word given right there. So we need to be careful with that. That's going to make us hone in on a certain category. So we are given that they prefer American food. So we're looking right here. Okay. So our column total for American food is 68. So that needs to be out of 68. And we're asked for the probability that they're a student. So that's 57. Always highlight the information you're given, not what you're looking for. We're looking for the probability that someone is a student. But what are we given? So go to the given column and highlight that. All right, moving on to the next page. Histogram. So that is our bar chart. We threw in the lines to help you get nice straight bar graphs or histograms. So what we're going to do here first is we are going to count up the number. How many are there? No, 14. Like 13? 14. And then we plug that into our calculator, and that's what, going to be close to 4? Yeah. And then our length is the max minus the min divided by 4, and that gets us 1. So this is a little bit different than what we have done in the past, but it's just gonna be like this: 1, 2, 3, 4, 5. We're not gonna have a range of numbers. We're just gonna have those right there. And then how many ones? 1, 2, and then there's a 5, and then 1, 2, 3, 4, 5. 3s. 1, 2, 3, 4, and then 1, 2. And then down here, same thing. You're just gonna make sure they're equal width, and then you can just do it like this with labeling the bottom with a single number. And This is 2. And then the next one is 5. And then 4. And then 2. And then 1. And then it says make sure to label, but they don't even tell us what the data is, so we can just leave it like that. Same thing for the next one. I'm going to go a little bit faster for that one because I have the information here. So this is going to be the square root of 13, which is approximately 4. And then your length is always your maximum minus your minimum divided by the number you got right there. So these are going to be 9. So again, just be really careful when you're counting these out because you can make a silly mistake. Once this number is 9, you're going to start with your minimum and always add 1 less than that. So instead of 9, you're going to add 8, or you can count it out with your hands. And then you're going to see how many of these numbers fit into here. So we get 1, 2, 1, 2, 3. And then just set these up. Two, 3, 3, 4, and 1. And get your scales on these two. Okay. There's that one. Moving on. Standard deviation. So the standard deviation says how far is this data spread out from its center. And so this right here is the center of this graph. Would you say this other information is close to that center or farther spread out from the center? It's pretty close to the center, so that means that since it's close, the standard deviation is going to be small, so that's going to be 2. And then this one, we can say the center is like approximately somewhere in there. And you can see this data is way spread out from that center, so that one's going to have the bigger standard deviation. I'm going to do this 5-number summary by hand first, and then I'll do it in the calculator on the next one. So make sure you always order them from least to greatest. And then we're going to come in, so 4 and 22, 8 and 17, 12 and 17. So right here, that's our median right there. 15 min and max are nice and easy. And then from here, what we're going to do is we're going to look at the first half of the numbers. Again, always ignoring your median and find the middle of those. So that's going to be the 12. And then we're going to look at the second half and get Q3, so that's 17. And then now we just have to graph these. So I'm going from 4 to 22, so I'm probably just going to scale these by 2, 6, 8, 10, 12, 14, 16, 18, 20, and then 22. So I have my scale on those. You can fill all those numbers in on your test. Here's the first one. I'm going to draw a line for 4. A line for 12, 14, so 15's in the middle, and then 17, and then 22. So the whiskers go out, and the middle is that rectangle cut into 2 pieces. Okay? So then for the Next one up here, I'm going to show you on the calculator. So on the calculator, anytime we're doing anything in this chapter, we're going to go to Stat and then Edit. And then remember, if you want to clear a list, you can just hit Clear when you're up in the L1. And then I'm going to type those numbers in. Ooh. Oop. And then from there, go back to Stat. And then this time you're going to scroll over to Calc. And then do the one variable statistics. And then just hit Enter. And then your calculator will tell you everything you need to know. So we have the min is 3. The Q1 is 3.5. Median is 10. 12.5, and the max is 15. So then we'll just do those. So we're going from 3 to 15, so I might just scale by 2s again. 3, 5, 7, 9, 11, 13, 15. And then I have 3, and then 4 would be here, so 3.5 is going to be really close to that. Then we're going to 10, then we're going to 12.5 and 15. So first and last are going to be the spaces, and then you have that rectangle. So this graph looks skewed right because do you see how most of the data is like on the left? And so this number 15 is kind of pulling it over that way. We don't have to answer that though. Next one says use this to determine the number of cats that weigh over 12 pounds. So all I do is I figure out what each height is. And then it does say over 12 pounds, which would be these guys right here. So it's just going to be 3. 3 of them are over 12 pounds. How to read a graph. Next one, how many miles, or what's her median distance? The median is always that center line, and so that would be 14 miles. Next one, he tracked his steps. What percent of his steps are less than 5,000? So here's where 5,000 is at. And less than is right here, and we know each one of those because it's quartiles and a 5-number summary. We know that each of these is 25%. Okay, so they're spread out. Some of them are more spread out than the others, so this is just going to be 25%. All right, last page. This is what we worked on yesterday with describing shape, center, and spread. So what you're going to do is just draw a smooth curve. Your first S is the shape of that curve. If you were standing on top, you would be going down the hill that way, so you'd be skewing left. So skewed left. And if the data is skewed at all, you're going to use the IQR and the median. And these two always go together. So you wouldn't use the IQR and switch to the mean. It's always median and IQR. Next, same thing on this one. Smooth curve, shape, and this is going to be skewed right. And then again, because it's skewed, you're going to use median and IQR. And then this last one right here, if you look at this box plot, you kind of just want to compare like this half and this half. Unless there's a really long tail, it's kind of hard to tell, but this is going to be symmetric, roughly symmetric. And if it's symmetric, then we use the mean and the standard deviation to get our info.